Given the arithmetic sequence 7 plus 12 plus 17 and so on up to infinity, and asked to determine the value of term 91 for 3 marks. So the standard form is Tn is equal to a plus n minus 1 times d, where a stands for the first term and d stands for the common difference. Okay, now the common difference is found by saying term 2 minus term 1 or term 3 minus term 2. So let's take term 2, which is 12, and subtract it with the first term, which is 7. So the difference is 12 minus 7, which is 5. Okay, and then our a is basically the first term of the sequence, which is 7. So we're simply going to substitute from here. We know that a is equal to 7 and d is equal to 5. So we're going to say Tn is equal to 7, okay, plus n minus 1 times d, which is 5. Okay, Tn is equal to 7 plus 5 times n, that is 5n, and then 5 times negative 1, that is negative 5. Tn is equal to 5n plus 2. But we haven't answered the question yet. We're asked to determine the value of the 91st term. So term 91 is equal to 5 times 91 plus 2, okay, and then term 91 is equal to, using your calculator, 5 times 91, you should get 455, and then plus 2, term 91 is equal to 457. We're given the arithmetic sequence 7 plus 12 plus 17, and we're asked to calculate the sum of the first 91 terms. So the formula for the summation of its arithmetic is Sn is equal to n over 2 into 2a plus n minus 1 times d. So as to calculate the sum of the first 91 terms, so 91 over 2 into 2, our first term, which a stands for, is 7, plus 91 minus 1, and our common difference is 5, okay? Close the brackets. S91 is equal to 91 over 2. 2 times 7, that is 14, plus 90 times 5, okay? S91 is equal to 91 over 2 into 14 plus 450. S91 is equal to, you can skip all of these steps using the calculator. 91 over 2 into 14 plus 450, that is 464. And then S91, and then using your calculator to make things quicker, you can then say 91 over 2 times 464, 21,112. And then you're done. Again, given the arithmetic sequence, which is that one, we're asked to calculate the value of n, for which Tn is equal to 517. So now it's a bit different. We're looking for the position of this value in this arithmetic sequence. So our formula said Tn is equal to 5n plus 2, okay, from the previous question. And then we're looking for n, okay, so 517 is equal to 5n plus 2. And then 517 minus 2 is equal to 5n. 515 is equal to 5n. And then we can say 515 divided by 5, 103 is equal to n. So 517 is the 103rd term of this arithmetic sequence. So the following information is for a quadratic sequence. Term 1 is 3, term 2 minus term 1 is 9, and term 3 minus term 2 is 21. and we're asked to show that term 5 is 111. Now when you have a quadratic sequence, you should think of the second common difference. So there's a first difference and a second common difference. So the first term is 3, that's what we were told. And we were told that the second term, which is unknown in this case, is... Sorry, we were told that the second term, which is unknown, minus the first term is 9. So we don't know what this term is. So let's then say x minus 3 is equal to 9. So x is equal to 12. So the second term is 12. And then we are told that the third term minus the second term gives us 21. Again, this is unknown. So let's then say y minus 12 is equal to 21. So y is 33. So we have 33 over here, okay? Now we can find our second common difference. We only have our first common, we only have our first difference. Now let's find the second common difference. So 21 minus 9 is supposed to get 12. So the second common difference is 12. We can then use our formulas, which is applicable for the quadratic, in order for us to answer the question. So the second common difference is a formula for it, which says 2a is equal to the second common difference. In this case, it's 12. Okay, so you can then solve for a. A is equal to 12 over 2, and then a is equal to 6. The formula for the first difference says 3a plus b is equal to the first term here, which is 9. Okay, we can then substitute a. 3 times a, which is 6, plus b is equal to 9. 3 times 6 is 18, plus b is equal to 9. B is equal to 9 minus 18. B is equal to negative 9. And then finally, the final formula says a plus b plus c is equal to the first term, which is 3. Our a, remember, is positive 6. Our b is negative 9. And our c is our unknown. We're solving for c. Is equal to 3. So it's 6 minus 9 plus c is equal to 3. 6 minus 9, that is negative 3, plus c is equal to 3. C is equal to 3 plus 3. C is equal to 6. Okay? And then finally, we have now our formula. So Tn is equal to an squared plus bn plus c is the standard form for a quadratic. So our a is 6, and then n squared, our b is negative 9n, and then our c is positive 6. So we can now show that T5 is equal to 111. So term 5 is equal to, let's substitute each value, 6 times 5 whole squared minus 9 times 5 plus 6. So term 5 is equal to, if you punch all of this into the calculator, you're going to get 1, 1, 1. So you have shown that term 5 is equal to 111. So we're now asked to show that the general term is 6n squared minus 9n plus 6. Even though we have done it in the previous question, let's just show us, which means the previous question also has an alternative method of solving that question. But let's just do it again. So we would solve that term 1 is 3, okay? And then the first difference is 9, which is term 2 minus term 1 is 9, and then we were trying to solve for this part. We got it to be 12, and this is 21. Term 3 minus term 2, we got that this was 33, okay? And then 21 minus 9, that is 12. And then we solved using those formulas. 2a is equal to 12. A is equal to 12 over 2. A is equal to 6. And then we said 3a plus b is equal to 9. 3 times 6 plus b is equal to 9. 3 times 6 is 18, plus b is equal to 9. B is equal to 9 minus 18. B is equal to negative 9. And then we said A plus B plus C is equal to the first term, which is 3. So it's 6 minus 9 plus C is equal to 3. 6 minus 9, that is negative 3. Plus C is equal to 3. C is equal to 3 plus 3, and then C is equal to 6. And then the standard form for a quadratic says Tn is equal to an squared plus bn plus c. A is positive 6. Our b is negative 9n. Our c is positive 6. So we have shown that the general term is 6n squared minus 9n plus 6.